So now we're moving to optimizing 3D shapes. Okay? So when we're talking about optimizing 3D shapes, that means we are talking about volume and surface area. So we always try to maximize volume, again, because volume is the amount of space that we're taking up, or that you can fill it. And we're trying to minimize surface area. Because when we're talking about making a box or making a cup or making anything that you're gonna have to produce, right? You wanna minimize the amount of material you're gonna use to make that shape, okay? So we always try to minimize the surface area and maximize the volume. Now in the case of 2D, what did we say? What shape gave you the maximum or minimum? A square. With a 3D shape, it's gonna be a cube. Okay? Alright, so a cube has a maximum volume, and among all rectangular prisms with a given volume, a cube has the minimum surface. Okay? So when we're talking about a cube, let's say we have with a cube, so all sides are equal, so that's going to be length times length times length, okay, or A times A, or whatever you want to call it, S times S times S, whatever you want to call it, right? So what would be the volume of the of that cube? What's the volume of any rectangular prism? Length times width times height. So in this case, it's L times L times L, which is L cubed. Okay? Because it's L times L, which is L cubed. Okay? How about the surface area? So the surface area of any rectangular prism is finding the area of all the sides and adding them up. Right? How many sides do I have? 6. 1, 2, 3, 4, 5, 6. You see 3, but there's 6. Right? Does anyone have a Rubik's cube? Right? So we have 6. If you think about this, 1, 2, 3, 4, 5, 6. Right? But in this case, they're all going to be the same. What's the area of this side? L times L, which is L squared. Right? The area of this face. So the area of this face is L squared. I have 6 of them. So it's going to be 6. It's going to be, so the area of this is going to be the same as this, the same as the back, same as the side, same as the top, same as the bottom. Because they all have the same side length. Do we all understand that?
So there's basically no width.
There's no what?
You're saying that
Width.
there's basically
No width. The width
width.
is the length. And the height is the same as the length. Right? I can call it S if you want, if you prefer, other than that. Okay?
LWH, that's confusing.
So do you want me to put it as S instead of L? Side?
Yeah, I guess.
Yeah? Okay, we can
It's
do
more,
that. So I can do S, 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 right? So that's gonna be,
First question, why are you not saying LWH? Is it because they're all the same
that's
length?
right.
I think that's what you guys are trying to figure
Yeah,
out.
that's right.
Why you're not putting LWH? So the
Because
reason is
LWH is the same side length. So I don't have to give them different letters when it's exactly the same.
So when would H become a factor? When, if it was a, because
If there were different lengths.
If it's not a cube.
okay.
In the case of a cube, all side lengths are the same. Same as a square.
Okay. So is there such thing as a rectangular cube? No.
No, there is a square-based rectangle, square-based rectangular prism. where you have the same side and side, but your height's gonna be different. Right, but that's not the case that we're talking about right now. We're talking about a cube.
But yet we're still using the formula for a rectangular prism to find what lies to this unit here.
It's the same thing. It's just straight.
It's the same thing. Instead of using W and H, I'm using S and S. Because it's exactly the same length. Okay? Alright. So, it's the same idea of when I use the square. It's just except I'm using different formulas. Okay? So, if the volume is given to you, you're going to start with the formula of the volume. You're going to isolate for S. Right? And then you're going to use that value to find the surface area. If you are given the surface area, then you're going to start with the surface area formula, solve for S, sub it into the volume to find the volume. It depends on what is given to you. Okay? So, what dimension produced a minimum area of a rectangular prism with a volume of 1,000 centimeter cubed? So I'm looking for the dimension. Minimum surface area given the volume. So what do I start with?
The volume.
Surface area formula?
No, the volume, we have the volume. So you start-
They gave us the volume, so we have to start with the volume. Okay? So the volume is S cubed.
L volume.
I know that the volume is 1,000. Now, how do you solve for S?
That's that thing root thing, cube root.
Cube root, that's right, cube root. So it's a root, but with a 3 on the outside. Because to get rid of a cube, you do cube root. If you don't know how to do that on the calculator,
Isn't the same, guys? Just do it with a tree. That's the one with the tree. Oh.
There's one that has a tree.
Over here, I see it. Yeah.
3, that's it. Okay? 10. So it's going to be a cube with side length 10, right? So 10 by 10 by 10. That's going to give me a volume of 1,000.
Okay.
Now, what would be my surface area?
So it would be 6 times 10 squared.
That's right. So you have 6 times 10 squared. So it's going to be 600, what's a unit? Centimeters.
We're not coming from 10.
Sorry?
We come from the dimension at 10, so it's now we're at the surface area. So we use the what we call it.
So
Because I want to find the surface area.
Yeah.
I know that my side is 10. So it's going to be 6 times 10 squared. Are we okay with this? So, make sure you write your therefore statement, because you probably didn't do 6 bracket 10 squared.
I can't multiply first and then square it.
What are you going to multiply 6 times 10?
Yeah.
No, because benchmark tells you you have to do the exponent first.
Okay, so then I'll do